So first of all, I hope everyone had a great weekend. We had an amazing session from Radha last week, and he kind of set the benchmark as to what we can expect from Polkadot ecosystem. And furthermore, we'll be going into the substrate and the framework, how you'll be working on. Then next step will be guided building. After that, working on building your own tab suits. So things are going to go uphill from here on. And it's going to be quite a journey. So hang on and keep focusing and keep trying to ask as many questions as possible. Try to stay up to date with what we are teaching here. All right. Before we move on to the session, I hand it over to our developer advocate, Mr. Deepak Chaudhary. Let me just take a comment from Praveen sir as to what you would like to say about our journey hitherto and obviously what lies ahead. Praveen sir.
Well, thanks, Deepak, and good evening to all of you. So I'm sure from last session, Radha session, you would have got some peek view into how exactly Substrate works and what are the technicalities. I think that video recording would also be posted in the group if we have already not done. I think we would have already done that. But more importantly, I think what we will try to go and do in next few sessions is Deepak Chaudhary trying to connect the rest what you have been learning so far with Substrate, and then we will start appreciating things a little bit more, right? Having said that, again, like I always say that it is quite possible that everything that is being said here may not really make sense to you because you are still early. But don't worry about that. Be persistent. And once we are done with these sessions, and once we start the guided building process, which we will explain to you in a couple of days' time, try to strengthen your foundation right now, okay? And so that you can maximize your learning from the guided building process, okay? I'll not take much time today. I think I'll have Deepak Chaudhary talk about what he really wants to share with you all. Please focus on what Chaudhary is saying and try to learn as much. Like Deepak Singh mentioned, please be interactive, ask questions. That is very important. If you are just on the listening side, then you may not get as much as you should, right? So please be interactive, ask questions, and try to trouble Deepak Chaudhary. Okay, Deepak Singh, that's pretty much from my side.
Yeah, so troubled Mr. Deepak Chaudhary as much as possible. I think that's not exactly what you would want to hear, but I mean that should be our agenda. All right, so Mr. Chaudhary, take it away, please.
Yeah, thank you, sir. My screen is visible.
Yeah.
Welcome to Kick Substrate Collective Workshop, right?
Yeah.
Yeah, okay. Hey everyone, Deepak Chaudhary this side. So today we are gonna aggregate all the information that we get in module 2, and we'll see how we'll be using Rust in Substrate. First thing first, I have one request to all of you. Please do not try to go in depth in your first stage. First understand the thing in a wider way, and then slowly understand the depth. Otherwise, I'm telling you, the things would mix up and make it very complex. So please avoid that. And if you have a misconception that we should have all the knowledge before starting something in Substrate, so that's not a case. Whatever you know, just start step by step and you will get it. And yeah, I'm gonna ask you some questions on Rust concept that we have already covered in last few sessions. Okay. I'll take the questions in the middle, and if otherwise I'll will take the QA at the last. Okay. So today we'll do a Substrate collective workshop. This workshop has two parts. One is fundamental and other is implementation. So if you understand the fundamental, then the implementation would be very easy. It's just a copy and paste. In today's session, we'll do the fundamental. As a homework, you will be doing a implementation part. You can see here fundamentals, and the workshop starts from here. I'll let you know what you need to do exactly, right? Okay, to do anything on Substrate, first you need to have a system ready, or you have a system set up in your local. Regarding that, I have shared so many resources, so many documents, video links. Can I ask you one question? How many of you have a Substrate in your system? Please raise your hand. Very few. Okay, you can down your hands. Let me give you a brief. Okay, let me first share this link with you all. Okay, here you can go the setup instructions, go to the install and choose your OS, Linux, Mac OS or Windows. Let me choose Mac OS first, right? And from this command, you need to run all the commands till this CMake, and the compiling a node will be take care of in this workshop. So make sure you have successfully run the command till brew install CMake for Mac OS users. For Windows, we have one extra thing, that is WSL, Windows Subsystem for Linux. To install that, you have this command WSL install, right? And then the command would be same as Linux, because ultimately you are working on a Ubuntu subsystem. So the command would be same as Linux or Ubuntu, right? You need to run successfully these commands till this. Just check the rust up version nightly and add the wasm. If you can see the message, this, let me show one thing in my system. Last step would be rust up show. You can see here rusty version and the stable version and all the nightlies that we have added, right? You should see this type of message in your terminal. Okay, so this is the installation part. After that, okay, what you can expect from this workshop? You will understand the basic pattern to build the chain in your local machine, and you will learn how we use Rust in Substrate and how to write a custom palette and how to integrate a by default palette in our chain. So this is the agenda of this workshop. Okay, let's go to the next. You can also install it by directly going to this link, right? And then if you are ready with the system setup, then you just need to clone this repository. Let me show you what this repository has. So this repository has Radha also shared this repository with you all, where we see two functions. Let me show you what are the two functions: do something and cause error, right? So we'll see what is this in today's session. Right? You will get all these files if you clone that repository. Just clone that and you will get all these files. Okay, the most important thing is this. This is the empty palette template. We'll fill this template according to our business logic. Right? Here you can see pub mod palette. We are defining the palette here in a modular way, right? Then we are using a frame support and frame system. Don't worry about this. We'll understand what these two terms are. Then we are defining the struct of palette. And then we have two things: define the custom types and defining the storage items. Let's say if you need to store some user data or transaction data. So ultimately you need a placeholder to store that data, right? So for that, we define a storage item here, right? And then we have defined a config trait. So config trait we have defined is to customize the parameter according to our need. Also to get the runtime event, as you can see here, runtime event, we need to define a config trait. This config trait is inherited from frame system. And here you can see event and error we have defined. So what event is, let's take an example in which after every block, after every 100 block, we should send some balance to X person, right? So on 101st block, how would I know the transfer is happened or not? So for that, we define an event. It basically notifies us whatever happened behind the scene, right? And we define error here. What is this? Let's take an example for this also. Let's assume we are working on a voting project and there are double voting is not allowed. And if a user tries to vote more than one time, then we stop that and we can say that double voting is not allowed, right? At last, we have callable function. We also call it as dispatchables. And this is the internal function which is used to fill the need of the dispatchables, right? Let me show you this empty palette in the default one. Let's compare one by one, right? Okay, let me do one thing. Can you see both the screens? And the font is clear, or I need to zoom it out? Okay. Just a minute. Here you can see we are defining a palette here, right? And then we are using the frame support, frame system. Then we are defining the structure for palette. And you can see here, we define a runtime event and the wait info. What wait info is, we'll see. Then we're defining the storage. Here we can see that we are storing U32 value in the something storage. This T is generic, right? Then we have defined the event. Right? If we store something in the something storage, right, then we should know what we have stored. And these are the errors that we have defined: none value and storage overflow. And these two are dispatchable calls. Here you can see that. Let me show you this. Right? Okay. Okay, let me show you the events and error events in live. Mhm. Okay, here you can go to the Explorer. Whatever event we define inside the palette, you can see here. Staking bounded, balance transfer. So we can see here that there is a transfer from account this to this, and how much is this, right? So we can see all the things, whatever happens behind the scene in the blockchain, in the events. Okay, let's get back to this. Where we are. Go to the next. Okay, what is substrate? We have understood this thing also, but let me give you a brief. Substrate is the SDK to develop our own custom chain in Polkadot network. In Substrate, we have one important thing that is called frame. It is a collection of pallets, right? And pallet, what are pallets are? Pallets where we write our own business logic, right? Let me show you. Yeah, here we have frame, right? In frame, we use two things. If you can see here, we use frame support and frame system, right? So what are these? So frame system is the system palette provides a low level access to core types and cutting edge utilities. It acts as a base layer for other palettes to interact with each other. Right? Example is like if we want to check the era, check the genesis, we want any interaction with the palettes, so we need frame system. Then we have frame support. Frame support provides a palette with a way to interact, create dispatchable calls, storage capabilities, events, and errors. What we have defined here. So these capabilities, let me show you. So we are defining the errors, we are defining the events. So these capabilities will get by the frame support. Okay, you can read this as a runtime engineer. Yeah, one more thing. We have one more thing in frame, that is runtime. So runtime is basically a state transition function. It keeps all the record of the state of our chain and also have events, errors, and it aggregate all the pallets, all the nodes, right? So if we want anything, if we want events, then we connect to the runtime and get the event, right? So you can see here, runtime provides configuration trait that allow developers to configure their palette by specifying the parameters. It allows.
Sorry to interrupt. Can you just zoom in a bit so that it's visible?
Just a minute. Is it fine?
Yeah, this is better.
Okay. It also allows a storage, events, and errors, right? And then dispatchable. Dispatchable, we have seen the functions, right? Functions such as transactions and other type of extrinsics. Okay. Now, the Rust types. First, we have enums. Can anyone tell me what enums are? Why we use enums? We have already seen all the rush topics in previous sessions here. Please, why we use enums? Let me hide this. Yeah, now tell me. Is anyone there? Yeah, okay. Anjali, I got your solution. Anyone else? Okay. So enums allow us, if we have a situation where we have more than one possible variants, then we use enums. If we see here, we are defining the direction, right? So in direction, we have up, down, left, and right. So for that, we use enums. Okay. Now next is struct. Struct allow us to package different types together, right? If you can see here, we are defining a struct my object. In that, we are defining a field one that has array of U8, and then we defining the field two. Can you tell me what option denotes here? What is the type of that option? Anyone? Okay, options come with the enum. So the type of option would be a enum. We have seen this in the session. So option have some or none. If there is any value in that, then it would be some or none. Right. Now third is field three. We have defined the field three as direction enum. Okay. Now we have drive attribute. Let's say you want to check the equality of two types, right? Then you need to manually implement the trait for it. But sometimes in Rust, we have these things already defined, right? You can see here encode, we have already defined, we have already by default have definition of encode, decode. What encode is, it is used to serialize, and decode is to deserialize, right? Then we have max encoded length. Max encoded length is when we have a vector and we need to set the limit of that vector, we use max encoded length. We'll see this term in the limits. Then we have runtime debug. It allow a type to print the errors in the console, right? Here we have already seen this clone and copy is to duplicate the object, and equal and partial equal is used to check the equality of two objects. You can see how we use this drive attribute. We just simply put these attributes above the definition of the struct. Now this struct have all the functionalities that these trait have. All right, let's go to the traits. What is traits? think of trait in Rust like a set of rules or promises that different type of things can follow. For example, a trait could be a rule that says if you want to be a superhero, you need to be fly or you have some super strength. So different superheroes can follow the rule by being able to fly and having super strength. So trait helps the types to follow certain rules or certain abilities, making it easier to write code that works with a lot of different things. Right here, you can see that we have defined the opposite trait and we define a function opposite. Then we have already definition of enum of direction. We define the trait opposite to the direction, impel opposite for direction, and then we can call this function opposite. Right? If we call opposite for up, then it will return down. If we call for down, then it will return us up. Right? How can you check that? You can check that by assert. Assert is to check the equality. Direction of left, we are calling the left of opposite, then it should be written the right, direction of right. Then we have advanced trait. This thing we have discussed. We define a config trait, which is inherit from frame system, right? And we define an account type and block number by this definition, T colon account ID. So what T is a generic. We are defining account as generic, and also the block number is generic. You can see here, right? We have defined the config trait, which is inherit from frame system. Let's understand the Rust generics, right? So Rust generic are like flexible tools that work with different kind of things. They let you write functions or structures that can work with various types without knowing the types beforehand. It's like a toolbox that fit many different tools, so you don't need to define a special toolbox for each tool. All right. Okay, here you can see that we have defined the account ID of U8, right? And in config trait, we have seen that we need to define account ID as type account ID. Sorry. Then you can see we are defining the palette as generic by placing these T. And also we are defining or implementing the palette with generic. Here in function also, we are passing the account ID as generic. But why do we need this? For example, in Substrate, most addresses are 32-bit, right? 32-byte public key. But what if you want to make an Ethereum compatible Substrate chain? And if you have hard-coded the type into your code, then you would never be use the different addresses. So for that, we make the account as generic. And for generic, we have two options. Either we use this or either we use this. Let me zoom out, zoom in. You can see here, we have two options, this and this. Okay, let's go to the next. Now we have a macros. So Rust macros are like a shortcut for writing codes. They let you create your own special words that can turn into a larger piece of code. It's like having a secret code word that can magically write a whole paragraph for you. So macro makes writing and reading code easier and faster. In C++, we have templates, right? And in Rust, we use macros. Just read this line. You should not spend your early days in Substrate trying to understand all of them, but rather just use them to make development faster. As you learn more and more about Substrate, you can then start to investigate exactly what these macros do for you and really come to appreciate how awesomely powerful they are. Right? So we have two different type of macros in Rust. First is attribute and function. Attributes macros denotes by the hashtag, and function like macros denotes by the exclamatory sign. Okay, so let's see this. We are ensuring the condition. Let me explain you how this condition will actually implement. What ensure will does, ensure will see this condition. If this condition is false, then it will reflect this error. And if this condition is true, then it goes to the next line. And in behind, you can see the implementation of this ensure here. This ensure macro, the implementation of this is here. The condition is the condition is false, then return the error. I think that should be clear. Okay, and where else we are using the macros, you can see here. We are using the macros in from starting to end. Here we are using the attribute macro. Then for defining the palette, we are using the macro. And here you can see for defining the structure, we are using the generic. And where else? Yeah, these all are attribute macros to define the palette, configuration, calls, and errors. Right. Okay, let's see blockchain limit. When you're doing contract development on a platform like Ethereum, so the EVM act as a limiter for what kind of logic you can run. Within the EVM, you are bounded by a gas limit, which means that any individual transaction can only execute so much logic and read or write so much storage. But Substrate gives you full access to write code as you like, rather than having something like the EVM meter for every line of code. Substrate allows you to benchmark your code ahead of time, right? And which is more efficient than EVM. Substrate version of gas, we call it as weight. You can see here, we call gas in EVM, and we call weight in Substrate. Okay. Now next we have runtime limits, right? Let's say we want to limit the number of entries in the vector, right? To make sure our storage will not overflow. So how we will do this? Let's see this example. We have defined the max limit of 100, U32 of 100. Then we have defined the items, right? Here you can see we have defined the bounded vector, and we are placing the struct, and the number of entries of item would maximum be 100. Maximum limit, that default. So we are limiting the number of entries of vector, right? And since the vector is bounded, so we cannot always guarantee that we can add a new item, right? We don't know, either we are on 91st place or 101st place, first place. So first we need to check, is this position is available or not. For that we have a function try push, my item dot try push. If this gets successfully pushed, then the compiler will go to the next line. Otherwise it will reflect the error, the vector is full, and this question mark returns this error to the main code. Okay, now next we have runtime storage. So mostly we have two types of we use two types of runtime storage. We have a lot more than two, so mostly we use two. First is storage value and storage map. If we want to store a single value, then we use storage value, and if we need a mapping from key to value, then we use storage map. Let me show you the example of storage value. Here you can see we have defined the storage value, and we are storing the U32 value into something storage. Okay, we'll see storage map, right? When we do the guided building, we'll see all the functions associated with the storage map. Here you can see that storage definition of storage value is this. We define the storage value and we are placing what type of value we need to store. Here we are defining a U64. And to define the storage map, we define the name here, and then we are saying that it should be a storage map, and this is the key, account ID, and the item would be a value, right? So account ID is a key, item is a value. So we have other storage like storage double map, storage counted map. So these are the some advanced version. Okay, how to get the information from that storage values or storage maps? For that, to put the value in the storage value, we use put function, the name of the storage and the put in the value. And to get the value, we use a get function. And if we need to kill the storage totally, then we use a kill function. These functions are for storage value. Now we have some APIs for storage map. Let me show you storage value here. Something, let's just go down here. You can see we are putting the something value in the something storage, right? And here we are getting some value from the storage. Okay, now let's see for storage map. If we need to check if there is any key which is present in storage map or not, if we need to check only the key, so for that we use contains key. Is it present in our storage or not? So we use contains key and the key. We put the key here. So this line means is the user key is present in item or not, and this should return a boolean value, true or false. If it is present, then it will return true, otherwise false. Okay, next, how to put the values. For that, we have a function insert. We have not put function here, we have insert here. So insert, we need to give a key as well as the value. User is the key and the value is the new items. Then if we need to get the information of a particular key, then we have a same function get, right? And if we need to delete any key, then we have a remove function, item dot remove and the key name. Okay, so this is it for fundamental. Let me show you what you need to do. First, you need to set up your system, right? For that, you can go to this setup link, right? After that, when you open, when you clone the substrate repository from here, right? Then you would see this type of files. Now what you need to do, just go to the palettes, go to the template, go to the lib.rs. Let me show you where this is already written. Substrate node template, palettes, template, source, lib.rs. Go to this and delete all this, right? After deleting this, just copy the empty palette here. Copy that and paste it in the lib.rs. Now you have an empty palette template. Then just go one by one. Not this one. Start at the config. Just go one by one. First, you need to copy this and see. Like, okay, so this line, what this line is doing is, this line is transfer the balance from to this user, and what amount is this amount. So just copy this all and paste it in your lib.rs, right? And if you want to see if my lib.rs is correct or not, then you can go to the solution and then you can match it from here. Your lib.rs should be thing like this. You until now you have only added the config trait. So my rest all are empty. Only the config trait is filled. And same things you need to do it for all the custom types. Just copy that and paste it in your lib.rs. Again, for custom type, just copy and paste, and see how we are using the storage, why we are using the storage. Like keep track of number of kitties, map the kitty structure to kitty DNA. If you want more information, you can read it from here. It is very simple. Just copy, paste, and read what are these lines are doing. Okay, so this is it for today. Now you can ask the question. Okay, so 2x64 concat is a hashing. If we need to store the storage map, so we need to hash that. So this is the hashing technique. 2x64 concat. It works like if and else. I think you are asking for ensure. Yeah, it works as well if and else. Anything else, guys? Setup link, let me share. Go to the install. I've shared in the chat for setup substrate. Can't see poll. I haven't opened the poll yet. Like, I'm asking if you have any question, you can ask.
Yeah, so I'm not seeing any questions, but in Q&A, Deepak, I think you've answered most of them. Chinmay, what is the reason behind using a single DNA for single kitties?
Is for single DNA is just a like project requirement, we can say. It's depend on you. Single DNA or double DNA, it's depend on you.
All right, so just FYI for everyone, there is no quiz or assignment that you will find on the platform, so don't worry. There's no such link or that needs to be activated or some info that needs to be shared. But what has been taught here is quite vital in itself and a little new for most of you. So what we would request you just go home and, I mean, when this session is over, go and practice it as much as possible and improve your skills on the same. Praveen sir, any comments? Okay, I guess Praveen sir might be distracted. So guys, we'll keep the floor open for another 30 seconds. If there are any questions, let us know. Devansh, tomorrow onwards, we'll be working with on making sure that everybody has a team. Don't worry, we'll fix it. But can you check the query from Anjali?
Yeah. So the installation of Substrate is just to compile the node. If you can clone the repository, you can now also see the lib.rs, but you can't compile the node. You can compile the code, right? For compilation, we need to install the Substrate.
All right, guys, I think that's about it for today. Thank you so much for joining in. Have a great night and try to practice as much as possible. Try to learn more and ask questions in the Discord server or WhatsApp, wherever you feel comfortable. See you all very soon. Have a great night ahead. Thank you all for joining in.
Hey, thank you, Ben.